So we've spoken about vectors and we talked about different operations that they have and we did a couple of application problems. So now what we're going to do is we're going to do the multiplication of two vectors, and there's going to be two different types. One of them is called the dot product and the other one's called the cross product, which is going to be in 3 dimensions. So we'll start off with the dot product. So basically if you have two different vectors, u dotted with v, then basically what that means is that you have u1, maybe, oops, that's wrong, u1, u2. So let's say the components of that was for u, and then the components for b was v1 and v2. Then basically what this means is that you're going to multiply the components together, u1 and v1, and add the components of the y values, u2, v2. So this is basically what the dot product is. Okay, so the dot product is just basically the multiplication of each component, and then you just take the sum of the products. Okay, so also here's another formula. If you want to find the angle between two vectors, then basically we have this formula called cosine theta is equal to the dot product of u and v divided by the magnitude of u and the magnitude of v. Okay, so you have these two different formulas. Okay, so the dot product, basically what you're doing is you're taking two vectors, multiplying them together, and in the end you're going to get a scalar. So you get a number at the end. You shouldn't get a vector. Here, what you have is that cosine of theta equals the dot product divided by the magnitude of v, u, and the magnitude of v. I'm not going to derive these formulas. These formulas will be derived for you some point in Calc 3, hopefully. But the formulas are not that bad. You're basically just using a lot of nice geometry. So one other thing to kind of know is that if the dot product, or if two vectors form a 90-degree angle, okay, then the two vectors are something called orthogonal. So just a very fancy word for perpendicular. So basically I have a vector going this way and a vector going this way, forming a 90-degree angle. That means that they're going to be orthogonal, okay? One of the vectors that you can kind of think about that are orthogonal is I and j. Because if you look at I and j, I has 1, 0, j has 0, 1. Now, and you can see that they form a 90-degree angle. Now, if you do that, if I take the dot product of I and j, so I get 1, 0 dotted with 0, 1, you're going to see that this equals to 0. So basically, one really quick way to know if two vectors are orthogonal is the following way. Two vectors are orthogonal if their dot product is 0. So if you know that the dot product between two different vectors is just 0 right off the bat, then you know that those vectors are going to be orthogonal. Okay? Alrighty, so let's do a couple of examples. Okay? Okay? Given the following vectors, let's say you had vector u be 3, 7, and then vector b be -1, I don't know, 9. Okay, let's find a couple things. So I want to find u plus 3v. Then I want to find u dot v. And then I want to find, oops, that should be point C, angle between u and v. That's what I want to do. So the first thing that we want to do is find the sum between the two vectors, and we're going to multiply the vector v by a multiple of 3. So you're going to take u, which is going to be 3, 7, And you're going to add 3 times v, which is negative 1 comma 9. So you're going to get 3 comma 7 plus negative 3 and then 27. So notice that 3 and negative 3 is just going to give me a 0. And then 7 plus 27, that's going to give me 34. So that's going to be the answer. Again, if you want to write it in ij form, it'll be 34j because you wouldn't have the 0j. There's the 0i. Now we want to take the dot product. So the dot product is going to be 3, 7 dotted with negative 1, 9. So the way that you do it, you take the two numbers, multiply them together, and take the sum of the y components multiplied together. So this is negative 3. This is 63. So it's going to give me 60. Okay. And now we're going to find the angle between the vectors. So the angle between the vectors is just using cosine of theta is equal to the dot product between the two vectors divided by the magnitude of each individual vector. So cosine of theta is equal to u dot v. So u dot v in this case is going to be 60 because we just figured that out, divided by the magnitude of u. So remember that the magnitude of u is just a square root of 3 squared plus 7 squared. And then we're going to multiply it by the magnitude of v, which is going to be this negative 1 squared plus 9 squared. So you're going to get 60 divided by, okay, so I got to use my calculator now. So the square root, so 3 squared plus 7 squared, that's going to give me the square root of 58. And this other one is going to be 81 plus 1 is 82, so the square root of 82. So now what I want to do is I'm going to take cosine inverse. So I'm going to write it over here. I'm running out of space. So theta is going to be equal to the cosine inverse of 60 over square root of 58, square root of 82. Okay, so cosine inverse is going to be 60 divided by the square root of 58. Times the square root of 82. And I end up getting about 29.5 degrees. Okay, so that is the angle between these two vectors. So that means if I were to graph these two different vectors in space, then the angle between these two different vectors is going to be 29.5 degrees. You can imagine that the maximum angle that this can be is pi, or 180 degrees. That means if the vector is pointing on one side and the other vector is pointing on the other side, the angle would just go about 180 degrees. Okay. Alrighty. Now here's the $1 million question. Are the vectors orthogonal? Okay. So the vectors in this case are not orthogonal. Not orthogonal. And why are they not orthogonal? Because the dot product is not equal to 0. So there's two different ways that you can do it. Part B can tell you that they're not orthogonal because they're not equal to 0. Or you can look at part C because the degrees is not 90. It doesn't form a 90-degree angle. So that's the reasoning why these would not be orthogonal. So later on, if you want, check these two vectors, 2, 1, and then negative 3, 6. So in your own time, are these orthogonal? So why don't you do it? You can do it either by taking the dot product or by taking the cosine of theta, the angle. Okay, so that was the first type of multiplication. The other type of multiplication of two vectors is what we call the cross product. Okay, so the cross product. And the cross product is very particular. So the cross product here, what we're talking about is in 3 dimensions. So in 3 dimensions, I'm only going to give you a little glimpse of what 3 dimensions kind of look like. So basically the plane not only has x and y, but you now have a z coordinates. Okay, so if I were to kind of, so you can have a little bit of perspective, you can kind of see that the z axis is just right through the middle, so you can kind of see that this is going to be the coordinate system that you will be working with if you take Calc 3 in later on, if you make it that, if you go that far, if that's what you got to go. But basically what this is that the logistics behind it is that you have two different vectors. So the first vector, vector u, is going to now have three components, a1, a2, and then a3. So and that makes sense because now you have a z component. Okay, and then you have vector v, and that's going to be, let's say, b1, b2, and then b3. So this also has three components. So basically what the cross product does is that the goal of the cross product is to find a vector that is orthogonal to both u and v. That's the whole purpose of the cross product. So you want to find a vector that is orthogonal to both of these vectors. Okay, so how do you find it? So if I have two different vectors in space, I'm going to try my best to draw this. I have a vector going that way, and maybe I have a vector going that way. How can I find a third vector that's going to form a 90-degree angle to these two vectors in space? So usually looking at it is going to be really difficult, but we have something called the cross product. So I'm going to first tell you what the formula is. The formula is horrible, but then I'm going to show you one way that I kind of like to do it. So the cross product is u cross v, not u times v, it's u cross v. And the way that you do it is the following way. So you're going to take a2, which is basically this guy, multiply it by b3, minus a3 multiplied by b2. That's your first component. The next one is a3 multiplied by b1 minus a1 multiplied by b3. That's your second component. The third component is a1 multiplied by b2 and then a2 multiplied by b1. Okay, so it's kind of horrible because there's no way that you would want to be able to memorize this. So there's a way that you can kind of do this problem without having to memorize this cross product. One thing to know about the cross product is that just how you have the dot product between two vectors, this gave you a scalar. The cross product between these two vectors, haven't been really nice with notation. The cross product between these two vectors is going to give you another vector. And this vector is going to be orthogonal to u and v. Okay, so the best way to kind of show you how I'm going to do it is by doing a problem. So I'm not even going to look at this formula. This formula is there, but I want you to be able to use this method because this method will be more useful to you. So what I want to do is, let's just do an example. So given the following, u is equal to 0, -1, and 3. And then v, vector v, is equal to 2, 0, -1. Okay, so this is how u cross v is going to work. So I'm going to cross the two vectors together. The way that I'm going to do it is the following way. Okay, so the first row, is going to, what we're going to write is I, j, and k. So k, imagine that one is going to be the vector in relating to z. So if I relates in the x direction, j relates to the y direction, k relates to the z direction. Okay. Now the second row is going to be the vector u. So basically the first one, 0, -1, and then 3. And then vector v is going to be the last one, 2, 0, -1. Okay. And the way that we're going to do this, and later on when we get to matrices, you'll see that it's kind of like the way that we find determinants. So the way that we're going to do it is we are going to work with I first. Okay, so I will be our first culprit. And the way that this works is that we are going to pretend that everything below it and everything to the side of it is gone. So we're going to take this minor thing, this -1, 3, and this 0, -1. Okay? So we're going to take those numbers. Okay, it's just a really weird way to do it. Then what we're going to do is we're going to take, now it's going to be J's turn. So what's going to happen is that these numbers are not going to alternate. This was positive, now this guy's going to be negative. So we're going to ignore the middle part and then the sides of J, and we're only going to look at this guy and then this guy. So those guys are going to be 0, 0, positive 3, and then 2, negative 1. Okay. And then finally, what we're going to do now is going to be K's turn. So now we're going to go back to positive. So this guy is going to be gone, and the top parts are going to be gone. So now I'm looking at the first one, and now the second one. So that's going to be 0, negative 1, 2, 0. Okay. A very weird way to do it, okay? But usually this is kind of how you want to think about the cross product, because this is what you're going to see now. You're going to take the I, and this is what you're going to do. You're going to multiply these two guys together. So first you're going to start off with the ones that are kind of like in the diagonal. So negative 1 times negative 1 is going to give me a 1. Then you're going to subtract it by 3 times 0. That's going to give me 0. Then you're going to have minus J. So you're going to multiply the diagonals again. 0 times negative 1 is going to give me 0. Minus the off diagonal. 2 times 3 gives me 6. Plus K. So you're going to multiply 0 times 0. It's going to give me 0. Subtract it by negative 1 times 2. Which is going to give me negative 2. So basically, if you look back at the original formula, you're basically doing that. You're taking A2 times B3. Okay, so A2 times B3, that's going to be, let's see, it's going to be this negative 1 times this B3, which is negative 1. That's a positive 1, which is what we got in the beginning, a positive 1. And then we're going to subtract it by B3, B2. So, I'm sorry, A3, which is 0. That's wrong. A3, which is 3, B2, which is 0, and which in that case is going to give me a 0. And you can keep going all the way around, and then you'll figure out that that's basically what you do. All you have to remember is this algorithm. Now, this algorithm works, and if you take Math 254, you will know that, and I'll give you a little bit of a hint of how this is actually working when we talk about determinants with matrices. So now what you end up getting now is 1 minus 0 gives me 1, so you're just left with I. Minus 0 minus 6 gives me negative 6 times another negative. That gives me a positive 6, J. And then this is going to be a negative and a negative. Give me a positive 2K. So since we had it in component form before, we're going to get 1, 6, and 2. So this is the cross product between U and V. Okay? So this, and I'll leave this as a little exercise. This vector, so what does this vector do? This vector is orthogonal to U and V. So that means this vector, let's call this W. Take the dot product between U and W, and then take the dot product of V and W, and you'll see that this gives me 0. Okay? Now, one more thing before we just finish this video. If U cross V is equal to 0, so let's say the cross product in this case was 0. What does that mean? That means U and V are parallel. Or another way to think about it is anti-parallel. And what that basically means is that the vectors are going in this direction, okay? Or the vectors are going in the opposite direction, okay? Which means that the only vector that's perpendicular to both of them will just be 0, okay? So that's basically how you can kind of think about the cross product. It's a little bit different than the dot product because they do different things, but this is kind of what I want you to be able to know. What does it mean when the cross product and the dot product are equal to 0? How to do the dot product, how to take the cross product as well.